Hi guys, I am Mushakwa and I am back with Math XYZ, and today I will be taking you through translations and reflections of graph. Graphs can be shifted both vertically and horizontally depending on the kind of translation that it has been subjected to. So let's look at one of the standard equation of a parabola, which is f at x is equals to a into x minus p squared plus q, of which we already know that p and q are the coordinates of our turning point. So when we are dealing with translations of graph, our p controls or is responsible for the horizontal shifting of the graph, and q is responsible for the vertical shifting of the graph. So for the first example, I will only deal with p, which is responsible for the horizontal shifting of the graph. So let's look at a function which is f at x is equals to x squared. F at x is equals to x squared. Looking at the one of the standard equation of parabola, if our equation is equals to x squared, that means that our a is equals to 1 and our p and also q, they are both equals to 0. That's why the function of f at x is equals to x squared has its turning point at origin of 0 is to 0. I've already drawn it, of which the turning point of this graph is at origin, which is 0 is to 0. Then let's look at another graph, which is g at x, of which g at x is equals to f at x minus 2. It's equals to, which will change the equation to be x minus 2 squared. So looking at the standard equation, that means that our a is equals to 1, and then our coordinate of the turning point, which is tp, is equals to 2 and 0, because we don't have anything of q, I mean to say, but then our p is equals to 2. That means that our turning point, the coordinate of our turning point is 2 is to 0, of which I've already drawn the equation, the graph of g at x, which is turning at coordinate of 2 is to 0, which is also our x-intercept. Then from there, let's draw our graph. Let's have another graph of h at x, which is equals to f at x plus 2, which will change the graph to be x plus 2 squared, of which the coordinate of our turning point, it would be negative 2 is to 0, because we don't have anything of q, but then our p is equals to negative 2. That's why our graph has a turning point at negative 2 is to 0. I've already drawn these three graphs, of which the graph of g at x and h at x, they have a point of intersection at the y intercept of 0 is to 4. But then what I need us to look into is the shifting of the graph. If we add a negative unit to x, that means that our graph, it will shift to the right. As you can see with g at x, we have added negative 2 into our graph, our original graph of f at x. Then the graph has shifted a bit to the right. As you can see that our original graph is this one, but then the graph of g at x, it has moved its turning point into the right. But then if we add a positive unit to x, that means that our graph will move a little bit into the left. As you can see that our original graph f at x is this one, then we add 2 into our original graph, and then the graph has shifted into the negative x, which is to the left hand side of the axis. Then we can make a conclusion that if we add positive into the x, then the graph shifts to the left, but if we add negative into the x, then our graph shifts to the right side of the axis. Thank you. And then alright guys, another example that we will do is when we are looking at only concentrating at q on the vertical shifting of the graph. So with the graph of f at x into a into x minus p squared plus q, we know that q controls the shifting on the vertical axis. So let's look at a graph of f at x is equals to x squared again. So the graph of f at x equals to x squared is the very same graph that we have drawn in the first example, of which it has the turning point, its turning point at an origin of 0 is to 0. Then now let's look at a graph of g at x. The graph of g at x is equals to a graph of f at x plus 5. So it's a graph of f at x plus 5. This time you can see that we are only concentrating at q because it's a plus 5, not at the x. Then that makes it x squared plus 5. Then we know that our p is equals to 0, but our q now is equals to 5. So with this one, we know that our turning point, it will be at a 0 is to 5, of which this is our graph of g at x with the turning point at a coordinate of 0 is to 5. Then the third one, let's look at a graph of h at x, of which our graph of h at x is equals to f at x minus 5. That makes it x squared minus 5. From this graph, we can see that our p is equals to 0, but then our q is equals to negative 5. Then our turning point, that means the coordinate of our turning point, it will be 0 is to negative 5. Then this is our graph of h at x with our turning point at 0 is to negative 5. Then from this three graph, we can now conclude that if there is an addition to q, then our graph shifts up, but if there is a subtraction to q, then our graphs moves down. This is what we see here, that our original graph is at an origin, but when we add something to q, then our graphs goes up, but if we subtract, then our graphs goes down. So this is a conclusion that we can make, that the graph can be shifted up if it's positive q, then our graph can be shifted down if we add a negative units to q. Then I hope you guys understand. Let's do a third example of which we see a reflection along the x-axis and along the y-axis. Alright guys, the third example that we will do is about reflections of the graph along the x-axis and the reflection of the graph along the y-axis. Then let's look at an equation of f at x. The graph of f at x is equals to x plus 2 squared plus 3. From this graph, we can see that our turning point, the coordinate of our turning point, it will be negative 2 is to 3. So this is our p, this is our p, and this one is our q. From this graph, the graph of f at x, this is what I drew here, of which the turning point is at negative 2 is to 3. Then let's look at another graph, the graph of g at x, of which the graph of g at x is equals to the graph of f at x into negative x. That means that in our equation, we will have negative x plus 2 squared and then plus 3 there. This is the graph of g at x. If you can look at the graph of g at x, that gives it the x coordinate of the turning point positive 2 and the y coordinate of the turning point is equals to negative 3 because of the negative in the x there. Then let's look at another graph, the graph of h at x. The graph of h at x is equals to negative f at x. Then that means that in our equation, what will change? We'll have a negative and then x plus 2 squared plus 3. Remember that we will have to multiply in the negative, this negative into the equation. Then actually we must have bigger brackets in there. We'll have negative, and this negative has to multiply into the equation. That's why our coordinate of the turning point is equals to negative 3 into negative 3. Then from this three graph, we can see that everything is equal in this graph, but only the reflection of the graph. So the mirror image of the graph of g at x, which is negative x, it's along the y-axis. And then the mirror image of the graph of h at x, which is negative y, it's along the x-axis. So we can conclude from these three graphs that the graph of f at x, if it's f into negative x, then it is a reflection along the y-axis. But if it's negative f at x, then it's a reflection along the x-axis. We can conclude from these three graphs that if it's negative x, then it's along the y-axis, but if it's negative y, then it's along the x-axis. It's a reflection along the x-axis. I hope you guys enjoyed and understood everything from this lesson. If you have any comment, please put it on the comment note and we will have a follow-up on it. And don't forget to subscribe to Maths XYZ so that you can get daily notification when we upload videos. Thank you.